Afternoon, everybody, and welcome to our April SAEON seminar. So just so you know, we are busy recording it and it's going to be put on the SAEON YouTube page. So you can find some of the older seminars there as well, if you're interested. And that we're also going to be having a little question session at the end. So please just stay muted and keep any questions you have for the end or pop them in the chat. And Marc will gladly answer any questions you have after the talk. So today our speaker is Marc Pienaar. So he is a data scientist and the acting data science lead for SAEON's uLwazi node. And he was really instrumental in putting together this the SAEON Terrestrial Observation Monitor platform, which is really useful in helping to explore some of SAEON's real-time data. So I'm going to hand it over to Marc so he can tell us a little bit more about what he's been doing with this and about this platform.
Thanks. Good afternoon, everybody. My name is Marc Pienaar. So this platform, the Terrestrial Observation Monitor, was something we released towards the end of last year sometime, with three goals in mind. The first was to provide data availability metrics on some of the live or near real-time sensors that SAEON operates. And that leads into a health barometer for technicians so that they can see when things are down or perhaps things aren't recording fully, maybe the batteries are getting flat or something like that. Then it was also to provide access to the public to SAEON's real-time or near real-time data via download, which is citable. And lastly, to provide a platform where we as SAEON can get data and develop processing pipelines and look at the data and figure out new streams to integrate with other systems out there. We do interoperate with a lot of the global systems at the moment, and there's some exciting things happening with Neon and Turn on harmonization, where we're looking at some of these raw variables and how we can harmonize those and standardize them. And then there's some internal functions and pipelines we're busy developing to filter out some of the messiness of this raw data and bring additional raw data into this platform in the coming months. And I'll talk a bit about that later. Okay, so just before I get into the talk, I just want to cement this really basic idea in everybody's head, since a lot of this talk is going to be about APIs. It's how the system connects and communicates with the real-time monitoring stations. So your typical, let's say, portal or website would comprise of a server somewhere, probably chopped up into virtual servers. And then if you wanted to create a static website, you would just host the code on that server and serve it via Nginx or Apache or something like that. You can use a content management system, perhaps WordPress, or just write something in standard JavaScript, CSS, and HTML. If you want a more dynamic system where it updates the whole time, you'd have to have a database and some processing functions sitting on the server in the back end. We use Postgres predominantly, but other databases are in use, of course. And then there's this green block here at the bottom, which is middleware. It's where you write your functions and your APIs to communicate between your front end and your database, your Postgres database. And I'm just going to explain briefly a little bit about what an API is so that it makes sense when I talk about the kind of live sensors that we're harvesting data from. So a typical API nowadays is something called a REST API, Representational State Transfer Application Programming Interface. That basically means that you can transmit data over the internet, over HTTP requests. And it has this anatomy. It's got a base URL, something like www.saeondata.com. And then there's an endpoint. The endpoint would be whatever you want to hit from your function. It could be station B temperature. Then there's a question mark and your first query. Do you want to look at its metadata? Do you want to look at get the data itself? And all additional parameters are followed by an and sign after that. So this is all standard. It's become standard. The HTTP methods are things like get to get data from a database, post to add new data through an interface to a database, update or delete. There's return status codes, things like 200 for success, 500 for some internal error, and so on. And then you can also pass header information, whether the user needs to be logged in, how you'd like the data to be returned. Should it be in a JSON, which stands for JavaScript object notation structure, or should it be in a HTML table, or perhaps even a CSV? It depends how you write the functions. So at the bottom here, these three panels, this is the typical layout. You'd have data coming into a database. This is a really silly example. It's just a table called users. Then you'd have some middleware code. This is written in Express as an example. And it's a get method, which says the endpoint is API users, and it will get all of the, I guess, fields from this table. And then you've got some front end. It could be a scripting language, it could be in a website, whatever it is. There's just a simple curl get command, and it returns the values in JSON format, which is quite a nice format. It's nested arrays and variables, so you can easily iterate through that and display it in various ways, either in code or on a front end. Okay, so at SAEON, at least for the terrestrial systems, it's predominantly the live stations use Campbell scientific instrumentation. And these would have various sensors all over the show, whether they be AWS, automatic weather stations, or flux stations, and they would link into some logger of some sort, which would record the data and then transmit it over the net to a server. And if you use Campbell Scientific, it comes with software called Loginet, which allows you to build simple little websites to show real-time data for the last, I don't know, 3 or 4 weeks or so. And then this little screen at the bottom is the sites we currently have live. It's just their locations, a lot of them on top of each other, but that's a zoomed out view. Okay. So when we look at the CSI web API, this is what Campbell Scientific produces for its Loginet sites. There's a lot of commands, but the two that are important for us are browse symbols. That's to get metadata. Allows you to see what sites are available. They call it servers. What tables exist in those sites, what fields exist in those tables, and so on. And then a data query command, which allows you to go and fetch the data itself from one of these metadata URIs, or unique kind of codes. So, okay, so here's an example. Just return it as an HTML table, where we say the base URL, the command is browse symbols, the identifier is just server in the format HTML. It returns a table of all the various sites, I guess, but let's call them servers that exist on SAEON's Loginet infrastructure. Obviously, I've truncated this. It's not the full list, but just to give you an idea. And there's a field here which says this can expand. On the right is just a JSON version of that. It's just a nested structure, which is easier to work with in a programming language. Then if we dig a little bit deeper and we continue looking at the metadata, but now we look at one of those unique sites, uLwazi Science Center AWS, we can return which tables exist in it, and it says it can expand further. So in the second command, we go to one of the tables and it returns which variables are on the table, and we eventually get to the end of the nesting where you can't expand anymore. At this point, you can take one of those variables, which is a field in a database somewhere on a server, and you can return some data. So this retrieval code at the top here that is just returning the most 2 recent, whenever I put this together, data points from whatever variable I'm returning, both in HTML table and in JSON format. Okay, now when dealing with raw data, it's obviously not all sunshine and roses, as you might expect. And this is a global problem. It exists everywhere. Over time, people might change the names of those static fields that they created in their database tables and the Loginet things. Sensors and loggers might go down. They might be stolen and new ones come on board. So it's a change in landscape. And over and above that, there's also different types of data coming through. There's flux variables and there's AWS variables. And tomorrow somebody might put up a site that has some other form of information that is transmitted live. So it's a bit challenging, which basically meant we had to come up with a structure that allows for dynamic names. So no hard coding is allowed. In other words, you can't create a table called uLwazi Science Center and the first field is temperature, because that might not exist tomorrow. So this is the basic framework, I would say, of the system. In the middle here is a representation of the database, Postgres database, and the middle column is the most important. It's got a table called servers, which are the sites, then the tables that belong to the servers, the fields that belong to those tables, and then the values that belong to those fields. So anything that goes in there is a variable. It's dynamic. Those are essentially just the column headings in that table, as well as a flag, whether it's active or inactive. And then there's a whole bunch of other side tables. There are a few more, but for simplicity, I've just shown a few. There's a unified mapping table, which allows us to take this raw data and provide a more summarized version, which users would see in the data tab, and a whole bunch of other things. These are controlled by a middleware code. It's a Node.js server or Node.js code called Express. It's a lightweight version of Node. And that controls the harvesting from Campbell Scientific, as well as all the functions behind these buttons. And then there is a public API for people to download data. Otherwise, it's just traditional download buttons and clicks and things like that. Okay, so to handle the variability in what could change tomorrow or in the future, there's an iterative process that goes through these 4 tables. So it starts off each midnight, or every day rather, at midnight. We hit the various loginet sites and say, does the server or site exist according to the database? If it does, it stays active. If it's changed its name, then the previous thing just becomes inactive and it becomes a new site. And then the same process happens. We iterate through each site and we go through each table and say, does the table in that site exist or not? So it's either the table doesn't exist, or it's a new table from a new site, or it's inactive, and likewise with the fields. So this is just a way to make sure that we archive the data and there's a timestamp of when changes happened, so that people who've got the metadata records of these things can line them up and do the processing and so on. And then some other functionality is just the data availability. So all of the data is stored in these field values, which we can link back up to a site through relationships, and provide some simple calculations that express the availability of each sensor variable on a daily scale. And this was useful because it's currently a SAEON KPI, but over and above that, it's just a really useful diagnostic for both technicians and people who want to see where data is available. You can do this at the site level. It lists the site and all the tables as an aggregate data availability, or you can do it at the site level where you select a table and it'll show you the data availability per variable. Okay, then I'm going to go through these next 3 slides relatively quickly and switch to the web browser to try and do an interactive version, just to show people how to get on here and all the functions and so on. But this is the page that'll greet you when you log on. It's the home tab. It's just a map with the various sites. There's clustered layers. If you click on any one of these, it'll highlight a site card at the bottom. And again, it's cropped, but that site card will give you access to the citation information, the metadata, as well as a button to go to the site. Alternatively, you can just click on one of the little dots and it'll take you right there. And then the rest of the tabs, what most people will see is a data tab, which comprise these expanded rows. If you click on a row, that's a site name. It'll expand and it'll give you the tables that are available to the public, where you can see the date range, what's currently available. There's processing always happening in the background to backfill these from historical things. You can view the citation details once again, the data availability, or just download a table, which will download all of it. These are calculated every night at midnight as well as a complete CSV. So some of them could be up to 500 megabytes, some of them up to a few megabytes, depending on the resolution you choose. There is a materialized view of the table. So it's not all the tables, it's just the last 30 days or so, because the data has grown at quite a rapid rate. So it's just a quick look at the data. If you want all of it, it's best to download it. And then obviously these data availability kind of heat maps. If you click on a citation detail link or something, it'll bring up the SAEON data portal, our catalog, SAEON's catalog, which links directly to the site. And then you can just click the citation. I'll go through that just now on the web to see how you can cite this. And finally, there's a few other functions where you can view how variables have been mapped to tables using, I guess, we'd call it computer code, not computer code, but machine readable code. It's all in snake case with underscores, so it's easy to digest via scripting languages and so on. Okay, this particular tab is not available to the public. This is role-based, and it's the Unified Mapping tab. This is just a screenshot of one of the sites where if you squint your eyes a little bit, you'll see the original names as they exist and as they were set up on the Loginet software and what they should be called. In other words, our renaming, which was done between myself and quite a large collection of SAEON technicians in a really nice, unified Go team manner, with some other things that you can change. And the minute you change these things and you say include in the summary tab, they'll automatically appear in the data thing. So we're currently working on getting the Flux sites or Flux variables, many of them, there are some of them, into the system at the moment. And then there's some other exciting things coming, which I'll talk about at the end. The Sankey at the bottom, it looks very confusing, but this is just two sites, and it shows how the relationship between the original names and tables and the new names and tables, since there were some overlaps in things called rainfall with a capital R perhaps, and precipitation or whatever. However they're set up, they're now standardized to a single name. I'm going to switch to the internet now. So there's a couple of ways to get to the site. The easiest is probably just to go onto the SAEON website itself and find the data tab, and there it is. You can do it through other websites that we maintain as well, like Sava and perhaps some of the Node websites and some of the international sites like GEOS. I'll show you that just now since we are interoperable with them. So if you go to the site, you're greeted with the home tab. And, you know, this is just the last 30 days, I think, maybe it's the last 2 weeks, I can't remember, of just rainfall measured from these sites, since that was a standard variable across all of them. That's daily rainfall. And then your standard zoom in and out. And if you click on one of these things and press go to data, it'll take you to the data tab and expand the row associated with that site. Okay, I'm just going to log in quickly. Okay, most people won't see all of these tabs. This is just a role-based thing, but it doesn't matter. To finish off the home tab, this function here was really just, you know, to be able to plot all the sites or cluster them. That was just for presentations, really, when you want to do that for my own sake. If you click on any one of these sites, it'll immediately go to the site card at the bottom where you can read a little bit about it. You can click view metadata and it'll take you to SAEON's data portal, and here's the site. This little button here, if you click it, brings up a citation record, which you can use if you download this data and use it in your publications. You just copy it to clipboard. And then there's just some metadata associated with that. Okay. If you go to the data tab, the very first thing is at the top. This is where the data availability stuff happens. So you can change the date range here. it is restricted to, I think, a year, which might be a little bit lenient at this stage, but to internal people, we can go back all the way because it's quite a massive calculation. So I've just left it as the last week for now. And if you want a quick view of all the sites, I'm just going to select a couple for visual presentation. Then it shows you the site name and the table, daily, hourly, 5 minutes, and so on. And at which point in time the data was available and how much of it was available. So that's an aggregate of all the variables that exist in each of those tables and so on. Sorry, I just had to move the thing there. This was that Sankey of the variable mapping I was talking about. So you can just see in this table, there's an hourly, 10-minute, and daily table. And some of them have shared variables just at different resolutions and so on. And then some descriptions, which we're still busy updating. Everything in red still needs a name, just in case people get confused by the funny naming here. Remembering that this is raw data, it's unprocessed. So it's not the stuff you'll see in the publications yet, but many scientists like to have the raw data and work things out for themselves. In fact, a really good analogy of this is something a good friend of mine told me. That is, if you go to a doctor and you don't like what you see, you get a second opinion. However, if you do like the results, you never get a second opinion. I found that providing raw data, you're always up for a second opinion because you've got access to the initial data, so you can make up your own mind. Okay, then in these tables, you can expand any one of these. It shows a date range of when the data was available or is available, and then an indicator when it was last updated. That's just a quick indicator, but these data availability tabs, so that's a materialized view, just to show very briefly, what's in this table if you want to see. I would say it's more for SAEON technicians and so on, just to have a quick view to see what the last measurements are if we need to go and do some filling and updating the code. You can then look at the data availability according to the time period you've selected. It says, okay, maybe we're too close to today, but perhaps that sensor stopped working, and you can do it for the various aggregates as well. That'll just take you back to the SAEON portal with citation details. And then if you want to download something, once you've logged in, you just say that you promise to cite our data, and it will download. And it's a relatively quick download. I mean, that was 34 meg, and then you've got a CSV in your download folder. The CSV, the very first line, does have the DOI in it. So if you click on that DOI, it'll resolve back to something like this. That's just for citation records. Then we've got the raw data. This was that active, inactive stuff I was talking about. And if you look at these numbers up here, you see that we're currently sitting at about 153 million records. The site grows by about 2 million records a day, every 2 days. It's going to expand quite rapidly as more sites come on board. And then a large portion of that has been filtered through this unified mapping in terms of naming and standardizing the names, at least, into the data tab, which most people will see about 77, almost 77 million fields, individual fields. The unified mapping table, I'm not going to go through. This is for internal functions instead of having to do this in the code, but it just helps a larger group of technicians who know their sites very quickly translate stuff into the data tab. Okay, there is a basic API ref, public one, that just downloads something at the moment. If you just follow these instructions. There are some private ones that are being developed, and we're working with collaborators, people like Neon and Turn for the harmonization thing I was talking about, and very likely with the FluxNet community through various projects related to FTON, the Expanded Freshwater Terrestrial Observation Network, going to look at how to get raw data via the background or via the back end for them to process and so on. And then finally, there's obviously an analytics tab that we can see. This is just for reporting purposes. So if you look at last month, got your standard, who visited from where. I think this person in America was doing a lot of API requests for one of the NEON things. And you can change those dates, and it's obviously got, standard analytics, which I don't think I need to go through. Okay, finally, as I said, we are interoperable. So if you go to a more well-known portal, perhaps GEOS, and you type in something like SAEON, unless you know the particular name, you should get to our metadata records. In fact, this is quite lucky. Most of them happen to be from this observation monitor as the first couple. And if you click on those, it should resolve back directly to the site where you can go and fetch the data. Okay, then I need to switch back to PowerPoint. I'm sorry, I'm just moving these hidden bars that nobody can see on this side. Okay, so this is pretty much how everything sits together or fits together at SAEON. It's by no means everything. I just try to make it visually easy to understand. We've got a system called the Open Data Platform, which is a bunch of federated portals all linked together, commonly joined by our catalog. That's where we get citation information and metadata, and we get our DOIs from DataCite and so on. And the public, those who have used SAEON's portal, know that they can submit environmental data you have for free, and SAEON will host it. But it's also a convenient way to link other systems. So we've got websites that we build, like the Bioenergy Atlas, SAVA, NCCIS, so on, where any data we refer to, these are static websites, links directly back to collections in the catalog. Then we've got interoperability. I've shown you the GEOS portal. There's a lot of work on the ocean side. It's not really my domain, but I know that we are linked to OBIS. I stand to be corrected through the MIMS catalog and SATCO and things like that. We're busy working with Neon and Turn on a harmonization process to get into Data One. That's one of the next steps as well. And then we've got systems that host their own data, like the system I've just been talking about, or SAEON's traditional observations database. And one of the advantages of having raw data now in the observations database is, in the background, we're working on pipelines to get them to human verified, cleanable, and slightly more automated forms so that they can feed into something like the observations database, for example, for people who are used to that. But either way, there are many ways to find this data through multiple portals, both globally and through our own catalog or through the sites themselves. Okay, and lastly, this is what's happening in the background at the moment. We've just set up a couple of terabytes worth of Nextcloud storage, so it's a nice interface, currently for all of the nodes to deposit their raw data. So that has a nice interface, drag and drop, and the raw data, it's non-deletable, there are restrictions and so on. We've set up another server in the background using various scripting languages and stuff, which will go and fetch this data, process it, and clean it. There's things like IPA-IP, which the Grasslands, Paul Bourdain has developed to clean some of the metadata. There's people working in FTON and other nodes, RB, etc., who have developed a lot of scripts, but they were all over the show. And now we're starting to bring together all our raw data. I need to check, but I think we're starting with boreholes and streamflow and some other rainfall stuff from hobo loggers and so on that aren't transmitted live, to bring into a tab as a raw data back into the observations monitor, and hence the pipeline to feed into other systems going forwards. And I think, albeit very short, that is the end of my talk.
Thank you so much, Mark. It's really great to see all the work that you've been doing and your team been doing in the background to try bring it all together and kind of advertise SAEON's data a little bit more so we know what's going on, but also from the SAEON side to try to figure out exactly what's going on at all of the sites and stuff. I'm going to open up the floor now to any questions. So you're welcome to raise your hand or pop a question in the chat if anyone has any questions or anything they'd like to say. No questions. There we go. Ryan, you're welcome to unmute and ask your question.
Hi, Mark. Thanks for a good overview and taking us into the basic steps. That was quite nice. And explaining the acronyms. That's also cool. So with everyone harvesting the data, are you able to track who's using it, or where it's ending up? Or I mean, you mentioned it for the reporting statistics, but there's the other side of the reporting as well, just to know who's using it. Yeah, what's that system look like? Thanks.
Yeah, I can show you what that system looks like if you like. So I assume I'm still sharing my screen.
Yeah, you good?
So when you log in, this is the importance of logging in. And I mean, it's really up to the individual. They can write whatever they want there, but this is one of the better ways to track who's doing what. Otherwise, you've got to tail the server logs and things like that. Then you've only got general information, what devices accessed it. But if you look at, for instance, something like there's a whole list of analytics here that can be reported, but really there's a summary report. But if we look at, I don't know, downloaded data, so there's been 31 occurrences last month of people downloading data, and this just shows the sites and things as a visual. Obviously the details are where you get those things, but on the top 20 chart, it's showing which sector people are downloading it from. But I could change this, for example, to country and discipline and so on. So if you look at users, this would be a logged in user. It would say that I've downloaded and these people have downloaded and so on. And there's a whole bunch of analytics. So every click and link that you do here, and even the API, you'd have to at some point add your username and password so that it accesses who's doing what to that. So it's fully trackable through the login button. And there are some other analytics which are traditional analytics. But the login's really very basic. It's just name, discipline, country. And that's about it really at this end sector.
Yeah, thank you very much. That's very nice to see.
Thank you. Sue, I see your hand up now.
Thanks, Mark, and thank you to you and the team for this. I'm super excited and very nice to see things coming together in a centralized way. You spoke about the code for data checking. I'm playing devil's advocate here, so some of the scientists are online. How the technical team and you guys have really led the way in this, but in terms of sort of deciding what is a level 0, level 1, level 2, level 3 checks, what do you anticipate the role of the SAEON scientists in coming into this process and actually guiding some of the scripting in terms of those different level checks, or not necessarily the actual scripting, but the definitions of and what should go into those for various variables?
Yeah, I think that would have to be domain specific. So this is clearly level 0. It's the it's the rawest unprocessed data you can get with all of its errors. The only filtering here is things like if the sensors start acting wonky or something like that and spit out dates from 1820, you know, when batteries start faulting. I just filter those out. But there's very little else happening here. So this is really just a raw unprocessed data. And I think level 0.5 or level 1, however you want to define it, is probably something where outliers, sensor problem has happened. Not gap filling or anything like that, but just getting rid of traditional things. And that's the stuff that would probably go to the next platform, which would be the observations database. I think Tim might be on this call. He can probably speak more about that. In terms of some of the other domains, this is mainly terrestrial stuff, flux and metadata. There's probably slightly different definitions for levels 1 to whatever, but I'd imagine level 3 or 4 would be analysis or rather derived products. It might be something, if you can think about satellite data, perhaps an NDVI product where it's gone through cleaning, gap filling, and then they've provided a seamless gridded NDVI or some derived product. Level 2 might be not the derived products, but the cleaned and gap filled products, and level 1 just the filtered products or something like that. But I think the scientists would have to probably come in and define how they want that per domain, and then the coders and other people would have to figure out the pipelines.
Yeah, thanks. I'm going to just jump in and say, so with the two, because you've got the central one, but then you said there was also the pipey one that Paul's developed. So just to give people the heads up there, what we've actually done there for the groundwater data is he's already put a lot of scripts together for automated checking and drift corrections and you know, how to improve get the data lined up with the dip meter readings and sort of various basic checks. And I think also with this, the Streamflow and the Met data, Michelle and Kent and Paul have worked together developing some scripts in terms of basic corrections there. So I suppose the invitation is to everybody working on these things who's interested is to please put your hands up and come and help with looking at these things so that we can get processed data out there in a consistent way. The one thing that concerns me, maybe Tim can come in, but as far as I understand from the OBSDB, for one phenomena, one sensor or whatever, it can only handle one version of the data. So if we've got multiple levels of checks in line, it might be the Terrestrial Observations Monitor, which could be the platform where those are stored, and then the final outputs or whatever on the OBSDB. But these are discussions that we need to hold as a collective between the technical team and the scientists. Thanks. I guess I've said enough.
Yeah, thank you. That's a really good point, because I was meant to end off my talk with that line of thinking, is that providing access to raw data serves an additional focus in a centralized place, and that's the ability to finally figure out how to develop pipelines and things like this in a dynamic way, rather than relying on scripts that sit on hard drives and computers and things like that, and then they're outdated next year and so on.
Yeah, thanks for that, Mark and Sue. I think, yeah, it's quite a nice way to start thinking about that data quality and how we get out like quality stuff that we can share, and the different points of having the like near real-time stuff and quality stuff for the future to use. Kathleen, I see you have your hand up.
Thanks, Caitlin. Thanks, Mark and your team. Wow, that's just so exciting. My question really speaks to this last slide that you've got up, that middle window, you know, where, you know, various different codes can be applied to the raw data and in some sort of pipeline. What do you foresee as the control, you know, the control point for that process? I mean, I can just see all this code coming in and who's going to decide, what gets applied, in what order? Is it first come, first serve? Have you guys mapped that out at all, or is this really still coming?
Yeah, it's early days, but I don't know if I can try and zoom in a little bit here. Oh, totally opposite effect. So currently, oh, it's a bit blurry, but currently there's some generic folders in our Nextcloud kind of database where all the raw data, SAEON's raw data that's been sitting all over the show is going to start coming in. And these are very high level. They're all empty inside at the moment, but it's got something called incoming, processed, project specific, resource documentation and archives. And the process staging folder is completely blocked in terms of write capabilities to everyone at the moment, except those who come forward and put up their hands and form committees. It's really only myself and Paul Gourdain from Grasslands and Aubrey from FTON who have access to write that. These other ones, they've got read and write, and the nodes need to decide how they're going to structure it inside there. So in the incoming, they can say Grasslands or whatever node it is, and then put the data there. And once that's set up, and that'll, it'll have to be through workshops and meetings, those cannot be deleted. This is something Cephii found out from experience, that if you give people delete rights, you start losing raw data. So if people make mistakes, it's an email, but essentially all of SAEON's data will eventually sit here. And once it's there forever. And once that structure is known, then it's possible to, so Paul, for example, is working in this server at the moment, anticipating some of the stuff he's working on will go into the incoming under some folder structure and just be fetched automatically for his thing to run and return to the staging and processing. But I would say certainly it's baby steps. We've just started this whole process. And I think there has to be some control and oversight, whether that's through a manager at SAEON or somebody, I don't know, but there will definitely be collaboration, of course. And once we figure that out, I think the next steps can start happening.
Yeah,
Absolutely. Thanks, Mark. It's useful just to see the pre-structure of the raw data and those different folders, just to imagine the way forward for the people who aren't intimately involved is really useful. Thanks.
Thanks for your question, Kathleen, and thanks, Mark. Yeah, I think it's great that we're starting to think about these things and figuring out how we want to do it, essentially. Sue, do you have another question or comment for us?
Just in response to Kathleen's question, so one of the ironies of SAEON is uLwazi has never been given dedicated MTF funding to cope with data coming directly from the SAEON nodes. It's a lot of contract funding, so we're really grateful to Marc for all the work he's done on this and for Leo giving him the time to do this. But essentially, when we had the technical workshop a couple of weeks ago, what emerged is the need for a dedicated role to sort of work between uLwazi and the terrestrial nodes that can sort of coordinate and oversee this sort of function, and then supported by possibly several data technicians who could then potentially support all the terrestrial nodes and FTON. And that is a recommendation that came out of that, that we will be taking to management next week. But where that goes, I'm not sure. But you're absolutely spot on, Kathleen. It does need a mandated person to coordinate and do this and do it in a co-created way as we did in the workshop. It was an incredibly powerful workshop, which we're seeing the results of that now. So yeah, agreed, and let's hope management listen and we get the resources to do this properly.
Yeah, thanks, Sue. And yeah, hopefully you can figure out how to make this best work. Does anybody else have any comments or questions that they'd like to add? Okay, I'm going to take that as no. I think that's actually quite a nice way to end, is thinking about like the way forward and how we kind of bring together SAEON's data a little bit better and have those end products out there. So I just wanted to say thank you so much to Marc for presenting on this, and I think people found it valuable. I definitely learned a bit, and it's nice to see kind of all of this data that SAEON has out there, or some of it. And thank you to everybody for joining today, and that I hope that you can join us next month. So our seminar next month will be on the 8th of May, and it will be by Dr. Joe Henschel. So he's the previous node manager at Aridlands, and he's going to be chatting about brown locust, but refocused. So I hope you can join us for that next month. Thank you so much. Bye.
Thank you.